Welcome to the new section of this course, Orchestration with Kubernetes. In our first video, we'll talk about the need for Kubernetes, and we'll look at some of the major challenges of running multiple containers, and then we'll explore Kubernetes and its features in detail. Before we go into the strong benefits of Kubernetes, we look at some of the major challenges of running multiple containers. When Docker came onto the scene, it provided an open standard for packaging and distributing containerized applications, and it took hold extremely quickly. As systems started to grow, however, it became obvious that it was not so easy to coordinate and manage multiple containers. Some of the questions asked were, how do all the different containers in your application communicate with each other? And how can container instances be scaled? Coordinating and connecting containers within multi-container and multi-host applications is particularly important for applications with the microservice architecture. For example, the overall solution to support an e-commerce website might consist of a cluster of containers running web servers that host multiple instances of a front end for failover, as well as other instances that have load balancing and a number of back-end instances and services running in separate containers supporting the system logic and processes. So as you can see, it can get quite complex very quickly. So there's an inherent problem in containers, also just like virtual machines. And this problem is the need to keep track of them and manage them. When public cloud companies bill you for CPU time or storage, well, then you need to make sure you don't have any orphan machines out there spinning out of control doing nothing that you're getting charged for. Apart from the monetary end of things, of course, there may be a requirement to automatically spin up more resources when a machine needs more memory, CPU, storage, and of course as well to shut them down when the load lightens up. Monitoring scalability is where containers exist in this twilight zone, somewhere between applications and hosts, where neither application performance monitoring nor traditional infrastructure monitoring are fully effective. And this creates a blind spot in our monitoring, which is a big problem for containers and the companies that adopt them. In any production environment, it is critical that we manage and monitor the system lifecycle processes. We need to be able to observe and monitor their state, as they are a very important piece of operations and management. Some questions that come to mind when considering operations and management of containerized systems are, how will we automatically recover when a container fails? Which upstream services are affected by such an outage? How can we patch our application with minimal downtime? How can we scale up our containers and services as our traffic grows? Networking and processing are also important concerns to be considered. Some processes are part of the same service and may benefit from proximity to the network. Databases, for example, may send large amounts of data to a particular microserver for processing. In this case, we need to determine how can we place these containers near each other in our cluster to minimize latency. Is there some common data that needs to be accessed? And how perhaps can we look at new services that need to be discovered and made available to other systems? Resource utilization is also a key. The small footprint of containers means that we can optimize our infrastructure for greater utilization. Extending the savings started in this elastic cloud will take us even further towards minimizing wasted hardware. How can we schedule these workloads more efficiently? How can we ensure that our important applications always have the right resources? How can we run our less important workloads on spare capacity? Finally, portability is a key factor in moving many organizations into containerization. Docker makes it very easy to deploy a standard container across various operating systems, cloud providers, and on-premise hardware or even developer laptops. However, we still need tooling to move containers around. And so we need to know how we will move containers between different nodes in our cluster, roll out updates with minimal disruption, and what processes we need to use to perform blue-green deployments or canary releases. Whether you're starting to build out individual microservices and separating concerns into isolated containers, or if you simply want to take full advantage of the portability and immutability in your application development, the need for management and orchestration becomes quite clear. And this is where tools like Kubernetes offer the biggest value. Kubernetes, also known by its abbreviation K8s, is an open source project that was released by Google in June 2014. Google released the project as part of an effort to share their own infrastructure and technology advantage with the community at large. Google launches 2 billion containers a week in their infrastructure and has been using container and container management technology for over a decade. Originally, they were building a system named Borg, now called Amiga, to schedule their vast quantities of workloads across their ever-expanding data center footprint. They took many of the lessons they learned over the years and rewrote their existing data center management tool for wide adoption by the rest of the world. The result was the Kubernetes open source project. Since its release in 2014, Kubernetes has undergone rapid development with contributions from across the open source community, including Red Hat, VMware, and Canonical. Since the version 1 release of Kubernetes in 2015, it's been a fast-paced evolution on the product with wide support from some of the largest open source communities on GitHub today. We'll be covering version 1.5 throughout this section. We'll explore how Kubernetes helps deal with resource utilization, high availability, updates, patching, network, service discovery, monitoring, and logging. The layman's definition of Kubernetes would be that Kubernetes is a cloud application platform that makes deploying applications easier. Kubernetes can be abbreviated into K8S, and that's because there's 8 letters between the K and the last S in Kubernetes. K8S is nothing but a cloud platform and open source container orchestration system. It helps to automate DevOps tasks such as deployments, scaling, and management of containerized applications. Kubernetes also helps in organizing containers into logical units that are pods and nodes. It will relaunch applications that have failed using a pattern called self-healing. Kubernetes will expose your applications as services and will load balance requests between multiple application instances. It is usually installed on the top of public cloud infrastructure service providers such as Azure. Kubernetes can also be installed in a hybrid cloud environment, with nodes of a cluster spread out across a private data center and also across Azure. While users can spin up Kubernetes on-premises or in the public cloud, the fully managed solutions and versions, such as those in Azure, available provide really great options. Now let's look at some of the key features of Kubernetes. The first feature is automatic bin backing. This feature distributes containers across different virtual machines on a network, depending on the required resources and other restrictions without impairing availability. The next feature is horizontal autoscaling. This feature can spin up and down new pods and nodes using cheap commodity machines. The last feature is automated rollouts and rollbacks. In Kubernetes, deployments are versioned, facilitating graceful rollbacks, storage orchestration, self-healing, self-discovery, load balancing, and finally, secrets and configuration management. In summary, Kubernetes is a cloud platform that sits at the highest level of abstraction. Its purpose is to provide a place for containerized applications to live and be managed or orchestrated.